Hello, hello. Everybody, go ahead and take your seats. We're going to get started. It's a great keynote starting out today with Sean, and now there's somebody else that I'd like to introduce to you, Eric Meadows-Jonsson. Yeah? He told me that I didn't have to try to pronounce it in any different way than what an American would. So if you've used Elixir, Eric is on the Elixir core team, but more than that, if you've used Hex, Eric, Ecto, Eric. So Eric, thank you, and I'm looking forward to your update.
All right, that will stay there, I hope. Okay, yeah, so I will be doing the update from the core team. So we will look at what we've released recently, what's coming next, and we'll mostly be focusing on the type system, since that's where because that's where we're spending most of our time now, and where most of the changes are happening. Yeah, so this is me. I've been on the core team for over 10 years now, spending most of my time, and I'm spending most of my time on Hex, as you heard. And I'm at Mechanical Orchard, where we work on accelerating legacy code and mainframe modernization. So we do new releases every 6 months or so. We're still on the first major version, so we haven't done any breaking changes since the release of 1.0, which is also over 10 years now. And there's currently no plans for releasing a version 2. So 1.18 is our current and the latest release that we shipped by the end of last year, and we can expect 1.19 in the middle of this year. So we will look at the changes in 1.18, do a quick recap of that, and then we'll jump on to what's changing in 1.19. So the last release was a fairly large release when you look at the number of new features. We got, of course, improvements to the type system. XUnit got some new features with groups and parameters. Mixed format got the new migrate flag, and we also got built-in support for JSON. So let's look at some of these in a little bit more detail. So in XUnit, we got the new parameterize option that you can see an example of here. And with the tests in a module can be run multiple times with different parameters. And just to explain a little bit how this works, we can look at an example from the core of the language itself, where we have the registry module, which is a scalable key value store. And the registry can be partitioned to improve performance. And the implementation of the registry works differently depending if you are using partitioning or not. So we want to test those two different modes. So we can use parameterize to do that, and still only write the test ones. So another thing is XUnit groups. As you probably know, we can configure our tests to run in async mode, which allows them to run concurrently with the other tests. But an important caveat there is that tests in the same module will not run concurrent to each other. And that's helpful when we're testing things with shared state. For example, databases that don't support transactions is a good example of that. The trouble with that, though, was that it forced you to put all of those tests into the same module, which could make code organization a bit difficult. So we got this new option, the group option, that says that all tests within the same group will not run concurrent to each other. So that makes the code a little bit easier to manage, since we can put those tests into multiple modules. So next up, we have the new migrate flag to mixed format. And mixed format has been around for a while now, and we always had the rule that the formatter is not allowed to change the syntax tree, and that's to ensure that we don't break things for users that use macros and the meta programming. But that changes with this new flag that's opt-in. So with this flag, we can do some changes to the code. So we've been so far using this to fix some deprecation warnings, to update the code automatically to the new recommended ways of doing things. But this will still have a low risk of breakage in most projects. But those that use macros may see breakage changes when they use this flag. So some example of this is we deprecated single quote charlist syntax. So now the recommended way of doing that, doing charlist, is with a single. So we can automatically convert that. Unless was deprecated in 1.18, so it will automatically convert it to a negated if. And in 1.19, we will also be adding parentheses to function calls with no arguments inside pipes. We also got JSON support in 1.18. The heavy lifting of this, of course, comes from Erlang that included this in OTP 27. And the API for JSON in the standard library will be very similar to what you've seen in other libraries that exist out there. And if you're using JSON, the JSON library, for example, it should mostly just be a search and replace to use the JSON built in to the language. And in some other news, we announced an official language server team. Up until recently, there's been various spared efforts to build language servers for the language. And that will bring all of those efforts into one team that will work together on improving the language server and the language server experience. And if you want to know more about this, there's a talk by Mitchell called Elixir LSP, I think. And I think that's tomorrow. So if you want to learn more about that, make sure to go to that talk. And another announcement that happened recently was the Open Machine certification. So we are complying with that now. So Open Machine is an international standard for open source license compliance. And we hope that this will make it easier to adopt Elixir for users that have rigorous supply chain and license validation requirements. Some other ongoing improvements that we're working on right now is improvements to documentation search. So today with Xdark, you can search with full text search, and you can do autocomplete on modules and functions. And we're extending this search now. So today you can do that on the current package version that you are looking at, but we're extending that so you can also search the latest version of the package and packages related to the package that you're looking at right now. So Higgs packages will be able to declare their related packages. So for example, let's use Phoenix as an example. If you're looking at the docs for Phoenix Live View, you will be able to search any other Phoenix packages that the Phoenix team has defined as relevant. And with this, we also get the new mixed text search task. So that from the command line, you will be able to search across all the dependencies in your project, which is really useful, I think. And the new Hexdocs homepage will get a little touch-up with some search, which this is a mock-up for that. And the package search, this is what the package search will look like if you search using the mix hex search tag. So you will land on this page, and in the sidebar you will look, so that in the sidebar you will have all your dependencies in your project, and you will search across them all. So let's jump into some of the new stuff in the type system, but before we do that, let's talk a little bit about what the type system is, so we're all on the same page. So we're using these words, set, theoretic, gradual, and sound, which are kind of daunting words, at least for me when I started understanding all of this. So let's go through this, and so we get a good foundation about what we're talking about, right? So one of the first things we say that when we talk about the type system is that we say that it's set theoretic. And that means that we can express types as sets, and we can do set operations on them. And to explain all this, let's use atoms as an example. So we can express literal atoms as their own type in the language. So each atom is its own type. And they are a subset of the atom type that contains all types, which is a subset of the term type, which is the superset of all the types in the language. And this is how we express subtyping. So pretty straightforward. And we can also do set operations on these types. So the union type we can express with the OR operator. So we can say that all numbers are expressed by saying integer or float. And this is similar to many other type systems that you've seen. And if you use dialyzer, this will be pretty straightforward to you. But something that is new are the not and the and operators. So with the not operator, we can say that type is any type except for the specified type. And this can be useful to express things like improper lists, where we want to say that the tail end of a list is any type except for a list. So we can express those things directly in the type system. The other operator is and, which we use for intersection types. And unlike unions, where when we're trying to compare types, the type only has to satisfy one of the types in the union. With intersection types, when we do type comparisons, we have to satisfy all the types in the intersection. And we can do some really cool things with that. So for example, we can say that we want a function that takes a parameter, and we want to do both do string interpolation, and we want to inspect this parameter. So we can say that we want a type that is the intersection of the string chars and the inspect protocols. And other things we do with intersection types is express the type for functions with multiple classes as well. We also say that the type system is gradual. So that gradual means that we can mix static and dynamic typing. And dynamic types are expressed with the dynamic type, which makes sense. And simplify, we can say that when we match a static type against a dynamic type, that type match will always succeed. So it behaves like a traditional dynamic type system. And to explain this a little bit, we can say that anywhere where we expect a static type, we can pass in a dynamic type, and if we expect a dynamic type, we can always pass in any static type, and that will always succeed in the type system. And another powerful feature of dynamic in the language is that we can wrap types with it. So if we have another union here between atom and atom and integer, if we treat that type statically, everywhere where we deal with this type, we always have to deal with both of them. So if we have a function that returns this union and we want to use this type, we always have to make sure that we handle both types, right? But if we wrap it with dynamic, as you can see here, we can treat it dynamically, and we can say that we only have to handle one of the types in the union. And the other thing when we talk about gradual is that we can gradually introduce types in an existing code base. So today we're only relying on type inference, so you cannot put any user-specified types today. But when you can, you will be able to gradually add types to parts of your code base, and that will get static typing. And the other parts of your code base will still use only dynamic typing. And another property we talk about when we talk about the type system is that it's sound. And soundness, when we talk about type system, means that when we run the program, it should behave the same way as the types in the type system. So this might sound like an obvious property of a type system, but not all type systems actually are sound. But that's something that we try to follow here. So a quick recap of what we have with the type system in the language so far. In 1.17, we introduced scalar types, or basic types such as binaries, numbers, atoms, and so on. We also added a complex type with maps. And in 1.18, we added to this with the inference of tuples and lists. We could also check function calls. And we had inference of patterns as well. So that's what we have so far. In 1.19, which will be coming a little later this year, we will build upon this. So we'll add to the pattern inference with guard inference. We will also be able to infer we will be able to infer whole function bodies, and we'll be able to infer protocol dispatch and implementations as well. So just to get a little bit better understanding of what this means, we can look at what some of the errors might look like when we that we can get from these new checks. And some of these things are being worked on right now. So in the final version, some of these errors might look slightly different. So for guard inference, this is quite similar to the pattern inference that we have right now. In this example, if we can infer that our first argument foo here is a number, and if we do an operation that's not supported, like binary concatenation, we will get a typing violation for that. And we'll also be able to do whole function inference. So we have the first function here. We infer that the return type is a number. And if we try to use the return type of that function for something that's not allowed, for example, binary concatenation that we have here again, that will also produce a typing violation. And finally, as the last example, we also have protocol inference. So for string interpolation that we're doing here, we can interpolate any type that implements the string charts protocol. And from the pattern in the parameter, we have inferred the range type. Range type doesn't implement this protocol, so we'll get, again, a typing violation. So all the type checking that we've done in the language so far has been based on inferred types. So that means that the compiler has figured out the types in our programs without the user having provided any type annotations. And as with anything, type inference has some trade-offs. Type inference can be more computationally expensive than if we just do type checking. The set of types that can be inferred is usually a subset of the types that can be specified by users. And as with metaprogramming, and when we use macros, we can create compile time dependencies. This is true for type checking as well. So inference, if you don't limit it, it can create large dependency trees that will require a lot of recomputation, even for small code changes. And finally, depending on how much type inference you do, you might get confusing errors from it, because it can produce very complex types. But we still want some type of inference, because being able to type check the language without having to explicitly annotate types has obvious benefits. And because of this, we made some decisions in the type system to kind of balance these trade-offs. So the first one is that Elixir has a two-pass system. So in the first pass, we do only type inference. And in the second pass, we do the actual type checking. But the inference in the first step will only look at function calls inside the current module, and it will only look at function calls to dependencies and the standard library. So it will not infer types from calls to other modules in the same project. And we do this to keep the type system, to keep it performant. And the other important thing to note is that inference is best effort. So it will not find all type incompatibilities. So for the best result, the user should be able to annotate their code with types, which we cannot do yet, but that will bring us to what's going to happen after 1.19. So what's next? So by the end of the year, we should hopefully get 1.20. And with that, we will introduce type structs. And I'm super excited for that, because it will be the first time the user will be able to specify types. And after 1.20, so probably in 1.21 or something like that, we will also extend those type annotations to include function signatures as well. So that's it for the Elixir update. If you want to learn more about the type system, we have some great documentation on hex docs. Make sure to add the /main to the URL to get the latest versions, to get updates for 1.19. And another great resource is the underlying paper for the type system that we're using. And I have to say, for being a paper, it's fairly approachable and easy to consume. And yeah, that's it. Thank you.
Thank you. Oh, there we go. Thank you, Eric. Let's see. I have one question online. Are there any plans to make mix hex search work with local docs if they are available? That's from Jack. He's right here. You could just read it, Jack.
No, I don't think so, because it will send you to a website. It will send you to hex docs, and that will be kind of tricky to integrate all of those things together. Maybe we can provide some local server that would be able to mix those things, but that's not, I don't think that's planned today, so it will only be like public hex packages for now.
Any other questions? Anybody?
I have a question. If I have a function argument that I'm pattern matching into an empty struct because I'm trying to get some runtime confidence that the argument is the proper struct, if I'm doing that, will the type inference system get value out of that in the short term or the long term?
Today, the only value will be that we know that it's a struct and possibly what struct it is, but it doesn't know anything about the fields today. And even in 1.19, that won't change. But in 1.20, when you will be able to specify types, it will get a lot of value from that. Yeah.
Any other questions? All right, let's give Eric a big round of applause.